Oh, is VC face not showing up? Oh, there we go. Perfect. Hi. VAFX Sinhara says, I want you to know I got a gambling ad for the stream because I forgot to set up Tamper Monkey. Oh no, Twitch is doing gambling ads now? I guess that makes sense, but hi all. Sorry the stream is late. I thought I had an appointment today, but after my streaming slot started, I got a call that said that the appointment was canceled. And I was already planning on working, but then I found something really cool, and I have been nerd sniped. Uh, Let me, before we get started with that though, I want to show you an amazing shit post that I found on the internet. So, incredulous underscore stare says, so how many framework desktop motherboards have you bought? Currently zero, because I am waiting for AI workloads to support them. And I have a powerful enough desktop already. But trying not to get too much into current affairs, but there's this the Pope has not been doing well. And the modern process of Pope election watching is going to be insane. But we live in the era of internet memes. So Pope has isolated bronchospasm, non-invasive ventilation started. Something fun about the phrase isolated bronchospasm. It has the same stress pattern as Teenage Mutant Ninja Turtles. Isolated bronchospasm. Oh my gosh. This is the level of shitpost that you need to aspire to. Like this is great. This is absolutely fantastic, and I think it's the kind of note that we need to start this on because like we need to laugh. We need to laugh. Either way, so let's get into the fun. Recently, I haunt the Go Slack, and one of the channels that I haunt in the Go Slack is the WebAssembly channel. Hello, Taito M4 Gatsu. And Go 1.24 added some features that make using Go with WebAssembly a bit more convenient. And then I found quite possibly one of the best things that I have ever seen. Where is it? Ah, so it is a type called string. And this string is a uint64. The way that this works is that in WebAssembly, you can pass primitive values from host to guest. And those primitive values can be signed 32-bit integers, signed 64-bit integers, unsigned 32-bit integers, unsigned 64-bit integers, and then the same for floating point numbers, as well as Boolean and I think void. Either way, another thing to keep in mind is that WebAssembly has 32-bit memory addresses. So, if you have 64-bit types as something native you can pass from the host to the guest, WebAssembly is 32 bits, and you can fit two 32-bit values into a 64-bit integer. What you can do is you can encode a pointer and a length into a 64-bit integer, and then you can pass buffers from the host to the guest. All you need is a function like malloc right here. Where is the guest implementation of malloc? Where is it? I made my own copy of it, but I need to find this copy of it. But either way, malloc, where you give it the length of data that you want, and then it will give you a pointer and the offset. So yeah, it's a better string, right? Taito M Forgatsu, right? This got me to look into the product, the project behind it, and then I found Yoke. It, the tagline is infrastructure as code, but actually. The TLDR is writing your Kubernetes manifests as code, as actual code that compiles to WebAssembly, instead of writing them with like weird templates like Helm or weird not code like you do with Q or one of the other things. Have you checked out the WASM component module? Makes add point hoc pointer juggling between guest and host boundary much more automated. I have, but there's not easy bindings for the WebAssembly stuff I use yet, so I'm just holding off until there is. I'm lazy. Ah, there it is. Thank you. For context, chat, David MDM91 is the person behind Yoke and the person that wrote this absolutely brilliant hack. I I love this hack so much. Like these two functions right here, the address and length functions betray the trick that's going on here. So you have address, which returns the upper 32 bits of the number, and then you have length, which shucks the left 32 bits off of the side, and then puts the left 30, puts the 30, or gives you only the right 32 bits. It's absolutely fantastic. If you write it as code, like fully Turing complete code, then doesn't that make static analysis of infrastructure as code much harder? Yes, but like, okay, this is we're only like 5 minutes in, and I'm already at the hot take part of the stream. But my infrastructure as code nuclear fire hot take is that configuration is just poorly specified ad hoc code. And at some level, you may actually want to just have real code, probably with like memory or execution time limits. I don't know. Either way, this is really cool. And today we're just going to play with it. I'm going to try my first. These are my first unfiltered views at it. I have only briefly looked over the documentation for one or two of the examples, but otherwise, we're just first reactions, hashtag first impressions. I'm going to be talking about what I'm thinking as I'm doing it, so yeah, it's going to be lots of fun. Oh, I do not want to be in PowerShell. I want to be in connect current window to no. I want to connect to WSL. Did that do it? It did. Perfect. CD code or CD code z make dir yoke stuff. Hello, Farcaller. Welcome to the stream. Hello, Medal of Death 1337. Welcome to the stream. Okay, so let's go into this folder that I just created. Z, and we'll go into yoke stuff. Okay. Awesome. Now, the first example here is we install the yoke command from either source code with the go command or the pre-built binary. You know what? Let's look and see what the pre-built binary situation is like. Pious Bird, sorry I'm late. Don't worry, I started late. Everyone's early. Okay, so Linux AMD 64, copy link, and then pop back to VS Code. Let's make a new terminal. CD cddl ls cd downloads. We wget this. And then tar xzf yoke. Oh, Oh, it's not a tarball, it's just a gzip file. Okay. Gunzip yoke mv yoke whatever to yoke yoki mv yoki yoke chmod plus x yoke tilde slash go slash bin. I would love to see this in homebrew eventually, but it's still early. I understand that this takes time. Now let's see if we have go bin in my path. We do. Perfect. So let's go to the documentation and take a look at a getting started thing. So it looks like the command that we're going to use is yoke takeoff and then the name of the release and the URL to the WebAssembly file. I don't know either, but I like that CSS is a lot easier to analyze than JSS because CSS isn't really Turing complete. I tend to put UI interactions in CSS if I can. Of course, not everything can be done with CSS, but it lightens my future burdens. Maybe we're both right, and IIC is just very hard to make useful enough without making it a scripting language. Yeah. Infrastructure as code, like, the problem is just hard. And I think it might actually be Turing complete hard in practice. I don't know. But CSS is actually Turing complete. If you count the browser, if you have it running in a browser. First thought when I had about reading about yoke is this reminds me of my Helm library, but instead of generating Helm charts, this goes one level deeper in interfaces with the Kubernetes API. This project's name is ungoogleable. Well, we'll get there. Okay, so first, we're going to start out by reading the concepts documentation. So, flights and yoke are analogous to hearts and Chelm. Wow. One of the great things about doing, like, video recording and stuff is that I have, like, gigabytes of footage of me just absolutely flubbing things like that. It's great. So, flights in yoke are analogous to charts in Helm. A chart is a collection of templates packaged as one referenceable entity. Similarly, in yoke, flights refer to both the code that describes Kubernetes resources and the packaged WebAssembly asset representing the executable. So, a yoke flight is the effectively Kubernetes templates and the code that generates it. Oh, yeah, the Doom on the TypeScript type system. Oh god, that is so great. My favorite part of that is that they implemented a WebAssembly VM in the TypeScript type system. Hey everyone, official Yoke Envoy here, so totally biased. Yeah, welcome to the stream. So, there's two types of flights. A flight is a piece of software that generates Kubernetes resources. In that way, even a Helm chart is a subset of flights. Refer to Helm compatibility for more information. Let's look at that at some point. This allows us to view flights at two levels, high altitude and low altitude flights, or high level and low level. High level flights are the programs or utilities / compiled WASM executables that generate the Kubernetes package instance for deployments. And the low level flights are the basic building blocks of the software. These are most likely represented as functions that take inputs and return Kubernetes resources. Okay, so the high altitude flights are like the entire program, and the low altitude flights are basically helper functions. Cool. We'll keep that in mind. Flight output. Flights are programs that generate a list of arbitrary Kubernetes resources to be applied as a single action. An output can be structured in three different ways: a single resource, a list of resources, and a list of resources. The quick question: what tool do you recommend I want to use if I have a virtual avatar? I used VC Face and something I converted from VRChat, but I kind of hate 3D VTubing. I need to get a 2D setup at some point. It's on the infinite to-do list. I don't remember what the best 2D tool is right now. I remember Inochi 2D was good at some point, but I don't know what happened to it. Either way, back to this. The first format is useful when using Yoke to manage a single resource over time. It's functionally equivalent to a list containing a single resource, but more convenient. The second format, a list of resources, is the most common type of flight output. This represents the set of resources associated with your release. So if your resource has a deployment, a service, and an ingress, then the second type would be all of those resources in a list. And then, this is one of the parts where, when I was reading the documentation, this really blew my mind as, like, this is a problem that I have encountered in the actual real world. They allow you to return a list of lists of resources. So the third format, a list of lists of resources, still is a single release, but the resources are applied in stages. This is useful for dependencies within a release. For example, if resource B depends on resource A being present in the cluster, we can deploy A in an earlier stage than B. Internally, a flat list of resources is treated as a list of lists where each inner list contains a single resource representing a single deployment stage. So the basic reason why you'd want to do this is with custom resource definitions, which is how you add your own types to Kubernetes. In general, custom resources need to exist before before things using those custom resources are applied. So what this would let you do is you can say, okay, apply this custom resource definition, and then apply the namespace, and then apply some jobs, then apply the database, then apply a job to create or migrate the tables, and then apply the actual deployment. Those are separate steps that have to be done in order, and there are ways to do this in other things like Helm and the like, but it's just suffering incarnate. Hi, Open Skies. Welcome to the stream. This yoke doesn't look much different from running Nix over Argo CD as a first glance, or running a WASI-capable binary over Argo CD, to be honest. Yeah, the part that really sets it apart is, I was going to get to this a little bit later, but yoke binaries can also read data from the Kubernetes cluster. So let's think about sounds cursed. It does sound kind of cursed, but it actually, I think in practice, it's actually useful enough that it makes up for it. Security-conscious users may wonder if granting flights access to the cluster introduces vulnerabilities. However, WebAssembly modules do not have direct access to the cluster. Instead, they interact with the host yoke program, which retrieves the requested resource and returns its JSON representation to the module's memory. The WebAssembly module cannot open sockets, file descriptors, or network connections. That said, this feature remains opt-in and is recommended for use only with trusted flights. In theory, if you had a malicious flight and you exposed cluster access to it, you could use it to I don't know, dump TLS certificates and post them off to God knows where, right? But I think this is a good enough trade-off. If it ever becomes a problem in the future, I'm sure there can be some capabilities or something that limit what type of resources you can access, or applying the rules from a role binding or a role. Either way, it's doable. Oh, you cannot access resources outside of the release? Oh. Oh, that's even better. Okay. Okay. Yeah, no notes. That's basically fine. That's like completely fine at that point. Like that's absolutely fine. Cursed Go fact. Um, Let me find the package because like Cursed Go fact. This entire file. Quote, Kubernetes is an API. You could just reload load resources, create new ones, and upload them to with any language, right? Yeah, I mean, at some level, this is just a more convenient way to do that. So here's an example of looking up a Kubernetes resource with the high level lookup package. Oh, so let's say you have a secret and you're naming it after the flight release with example as a suffix. And then you look up the existing secret by running kubernetes.lookup of type core v1.secret with the input being a resource identifier for a v1 secret named secret name in the flight namespace. And if it fails, then, blow up. But otherwise, return a secret. Oh, oh, this is upsert. Oh, 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 oh. Oh, 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 okay. What this is doing here is this is creating a Kubernetes secret with uh like the same name as the same generated name, and then its data has a password. And if the secret already exists, reuse the password. Otherwise, create a random password. The only marginally useful case I could see is generating passwords and reading them back. Writing a Go app uh, to create a resource sounds like that HTTP to Markdown SAS I saw the other day. Lol, literally use case I noted above. Yeah, I mean, like, the thing that I want to use it for is making a template for, like, my home lab apps so that I have, like, an opinionated template that just replaces the right thing. Yoke maintains a flight that generates TLS certificates. Makes sense. So, why WebAssembly? Yoke's goal is to enable software packages to write packages for. La, la, la. Yoke's goal is to enable software engineers to write packages for Kubernetes at code. The issue is that code is not easy to package, and code itself is useless without its runtime or compiler. Yoke would need to be able to get the appropriate runtime or compiler for any language, and moreover, it would need to get those dependencies compiled for the correct architecture and OS as where Yoke is running. This would be an enormous task. This leaves us with two options. Either accept arbitrary input as packages, or find a common target that many languages support. Yoke chooses both options? Oh. Oh. Yoke allows us to support any runtime, even those that don't compile to WebAssembly. This allows us to write flights in our favorite beloved dynamic languages. Huh. However, it comes with some serious drawbacks. There are no physical assets that we can version and checksum against, and arbitrary programs are running in a context that has access to your Kubernetes cluster. It's also like Pulumi with WebAssembly, apart from where Pulumi seem scales to whatever. I suppose it could also read how you first installed the release so it would know what resources to keep using. It could also find out what versions of stuff you have installed and if there are some upgrade migrations to run. The drawbacks seem pretty terrifying. Yeah, that's another reason why I kind of like this. Because, like, WebAssembly is a hard security barrier. A hard security barrier is a lot less permeable than a soft security barrier. So this allows you to do like arbitrary Turing complete computations, but because it has access to so little of the host and so little of the environment, it's way more secure than you'd think. With WebAssembly, we can solve all our problems, including the two mentioned above. We have a common target for multiple languages. We have a final asset that Yoke can track internally for changes. You have a runtime that is not dependent on OS or architecture. And you have a runtime that is sandboxed, as in it cannot access the network or file system. WebAssembly being sandboxed is a big deal for us. It eliminates side effects such as file system I/O and makes our programs deterministic. It buys us a measure of security too, given that should a supply chain attack happen in the dependencies of your programs, an attacker would not have direct access to your file system, the network, or your Kubernetes cluster. You run externally supplied WebAssembly code often? I mean, you use a browser, you run externally supplied WebAssembly code every day and you don't know it. But the example is you build a thing with GoOS equals WASIP1, GoArch equals WASM, go build -o main.wasm, and then the folder path to the folder of Go code, and you do yoke takeoff my release main.wasm. Okay, now I'm remembering when I was at a former employer, I learned that GoOS and GoArch are canonically pronounced goose and gorch. This is information that you are never going to be able to use, but this is information that you have now. Okay, let's look at the getting started page. Disclaimer: the following examples are written in Go, but any language that compiles to WebAssembly is a first-class citizen for Go. Writing it in Go allows us to take advantage of Kubernetes core API packages. Languages that do not compile to WASM can still be used but not benefit from Yoke's asset management. For more information, see why WASM. These examples assume some familiarity with the Go toolchain and that Yoke has already been installed. Writing your first flight. The most simple implementation of a flight is to write the resources you want to standard out. So for this example, we have package main. We import the format package, and the deployment is just a Kubernetes resource that creates something called example app with the label app example app. We have spec replicas too. We have a selector to match the right labels. We have a template that adds the labels to the pods. Our pod spec says that we're starting Nginx and listening on port 80. And, you know, like, yeah, this will work. You know what? Let's try this right now. New file. We're going to call this, actually, we'll make a folder for this. We'll call it, inline basic. We'll go to main.go. We'll drag the terminal down a bit. We'll hit paste. And then I'm copying the example command. Oh, right. I need to make a Go module here, so we'll do github.com/z/yoke stuff. I'm going to make this repo on GitHub when the stream is over. Okay, so we have a WebAssembly file called example.wasm. I am sweating. Okay, let's do a quick WAS0 run in example.wasm, and it just prints the stuff to standard out. So let's do it. Which cluster am I connected to? Kube context. Let's connect to the test virtual cluster. Okay, we have connected to the node, and now we can run yoke take off example ./example.wasm. I will open K9s in a new terminal so that we can watch it happen. ns, we go to the default namespace, and successful takeoff of example. Oh, look, it's created pods. We have created pods. The pods are running. You can sweat a little bit less now. Let's go back to the documentation page. And we're done. With this example, you have defined a valid flight, compiled it to WebAssembly, and had Yoke deploy the first revision of a release named example. However, this is a first example, but we haven't really gained any advantages of using code to describe our Kubernetes packages. The previous example is basically a convoluted way to run kubectl apply. Or, you just feed the YAML text directly to Yoke. Now that we understand types are simply programs that output the resources as JSON or YAML, we can start representing our resources as Go values using our own types and abstractions, or those provided to us by other libraries. As it happens, there's a Go package called k8s.io/API that has all of the Kubernetes APIs defined in it. The previous example was as unidiomatic as possible, but this time we can break down the construction of resources into their own functions and create any signature or contract we want. So I'm going to copy this example to the clipboard, and we're going to head over to VS Code, and I'm going to make a new folder. I'm going to call it typeful, or let's do Kate's API. And then we'll go to new file, main.go. We'll paste this, and the language server is going to complain because we don't have stuff there. So what I'm going to do is I'm going to hit save, and then I'm going to run the unbreak everything command. Go mod tidy. Okay, now that everything is fixed, let's take a look at what this is doing. So apparently Pulumi also uses the Kubernetes SDK for the types. Yeah. So starting with this code, in Go, func main is the entry point. So what this says is if error not equals if error is the result of the run function and the error is not nil, throw the error to standard out and then die with an unsuccessful exit code. So the run function starts out by declaring some variables. The first variable is the release, which is like when we ran this example, it's the example right here. The namespace is the argument of the name, is the value of the namespace flag. Let's actually just run -- help right here. Oh, it's got some nice help. Okay. So yoke takeoff flags, release name, flight path. The aliases are apply and up. You deploy a local flight by doing yoke takeoff release main.wasm. You can do gzipped wasm files. You can deploy a flight from a URL. You can pass arguments to it. You can pass data over standard input to it. You can pass static resources and, like the output of a shell command. And you can also diff it instead of actually applying things. Cool. There's some other flags like color, diff only, force apply changes on field manager conflicts. We'll figure out what that means eventually. The path to the kube config. Oh, that's very useful. We have a standard out for outputting flight resources to the directory specified. Execute the underlying WASM, output it to standard out, but do not apply any resources to the cluster. What does that mean? Oh, just echo what it would. Just echo the resources that it would output. Okay, cool. So we also have a common set of labels, like for example, naming the app, giving the app name the release. I will be using this when I implement my thing. So our resources is a slice of flight.resource, and a resource is just a generic parent of Kubernetes resources. One sec. Never get sick. I have been recovering from a weird cold that I got, and I've been coughing like 2 weeks after it. It sucks. I'm gonna try to mute myself when I am coughing, but I might mess it up. So then we create a slice of resources, and it's two resources. We have a deployment, which is a Kubernetes concept for a group of pods where you can update the pod config and it'll roll out new changes. And we have a service, which gives a DNS name for a group of pods and exposes things on exact ports. So the create deployment function and the create service function are what actually make the resources. And then we write that to standard out as JSON. You know what? Let's actually build this right now and see what it outputs. I'm going to pass -v to the go build command so that we can see all the packages that Go is building. As you can see, it's building a couple packages. Cool. And then was0 run example.wasm. Ah. Okay. Pipe Jake. Hello, Canara ZH. So we have a deployment, and it's named example.wasm, which makes me think that the release name is the 0th argument to the WebAssembly binary. It's very cheeky. I love that. I would have done environment variables personally, but I see how it does. Have you tried Yike? I have tried Yike. I'm just using Jake because it's like right there. So we see it outputs an array, and then it puts the Kubernetes resources in JSON. Cool. So our deployment config is a couple of things that just get slapped in as variables. So we have the name of the deployment, the namespace the deployment goes in, the labels for the deployment, and the number of replicas. It is very contrived on purpose. Yeah, I'm just stepping through this not only so that I can internalize it, but also to just show all of the code. So the create deployment function just returns a deployment, and it basically uses this as the template for it. But it's doing the templating very type safe, very type safely, because it's using the same types that Kubernetes uses internally, which I think is like a pro gamer move. So we let me scroll up. Let me keep these both in sync. So the name is example.wasm. There's no namespace defined, so that just gets left as an empty string, but it'll default to the default namespace. Our spec is that we have a selector, which is, the group of labels that we defined in the deployment config. And then we have a deployment that runs the Alpine image and says watch echo hello world. And it'll just say hello world over and over. Yeah, compared to Helm, where you're just concatenating together stuff and manually handling whitespace. Yeah. Ugh, I hate it. So let's see what happens if we run this. We're not gonna do the standard out command. We're just gonna do this. Successful takeoff of example. Ooh, it made new pods. Hello, world. I didn't know that Alpine had a watch in BusyBox. That's news to me. You learn something every day. But you can see how, like, you're basically taking inputs and then turning it into outputs. Thank you for the follow, Malphabeth. Malphabeth? Malphabeth. Oh my goodness. While we are on the stream, uh, one of the homebrew developers made a PR to homebrew for Yoke. That's amazing. Thank you for that, Shu. Let's go back to reading the docs. Let's see what else there is. So repeating its steps in the first example, we compile it, we deploy it, and then it's there. I hate Helm indentation juggling so much. Me too. That's why I'm so excited that this exists, because I was going to make something like this. But now I don't have to. It's great. We have created a second revision of our release called Example. It contains both a deployment and a service. It comes with all the advantages we expect from code. It has type safety, the dot key works, and documentation is a click away. We can break things out as reusable functions, create our own contracts, and write tests. The world is your oyster. In this example, we use the Kubernetes API packages to build our resource values. You may want to use the types resources directly, or create your own simplified representations. No more YAML hell? Yeah, I mean, this is a different type of hell, but, like, infrastructure is always hell, and it's a game of what compromises you're going to make. Configuring your flights. Again, disclaimer, these examples are written in Go. You can write them in any language. You can probably do it in Rust. It's fine. The reason why we're doing it in Go is because we have the Kubernetes API packages that Kubernetes uses directly. And you know what's better than writing code? Not having to. Flight configuration. In our previous examples, our flights have been static. Every invocation will return the exact same output. This is a valid approach, especially when you're reusing low altitude flight functions and want to take advantage of type safety and features provided by your coding environment. Changes can be applied by recompiling different configurations of the flight and versioning those assets over time. However, sometimes we wish to have one compiled program that can be invoked at deploy time with different settings. To achieve this, Yoke supports instantiating WebAssembly variables with WebAssembly executables with both flags and standard input. Let's take a look at the simplified deployment example, and let's consider how we would configure the replica count. This example is not fully runnable. The deployment is missing too many properties to be useful. This is a abbreviated example. But we create a deployment of types apps v1 deployment. The specification is that the number of replicas is 2, and because Kubernetes, you have to be a pointer to there. Confused how WebAssembly gets into this. There has to be a better way. The TLDR is that you could just do it with arbitrary programs, and Yoke does support this, but arbitrary programs can run arbitrary things, and WebAssembly not only is vendor OS and CPU architecture neutral, it's sandboxed so you can't access the network or the file system. The TLDR is that the threat model is like, okay, you run Python 3 app.py, one of your dependencies gets popped and you don't know, and then suddenly an attacker is running malicious resources in your Kubernetes cluster. That would be a bad time. WebAssembly makes it difficult to that. Yeah. Are you aware that you're developing a Canadian accent? I am aware. I'm not actually from the part of Canada where like people oot their boots, but I started doing it ironically to mess with my coworkers, and yeah, you can see how that would happen, eh? Okay. Using flags. So we have package main, we import the JSON package, we import the flag package. Montreal homegrown project. Oh, I'm over in Ottawa. I'm gonna be in Montreal at some point. We should meet up and have coffee, eh? I did it! I fucking did it again. Oh my god. But the Go standard library flag package is kind of amazing. Not enough people use it. Yeah. You define flags and then you pass flags on the command line. It's pretty simple. You can define your own types. I love it. So instead, we have replicas, which is a flag of type int that creates two replicas. We parse it, we create a deployment, and then we take that variable and splat it into the deployment specification. So you can see how, like, you have this replicas variable here, it gets put into this variable, and then it gets put into the deployment, and then it gets put into the Kubernetes cluster. Actually, you know what? Let's hack this in right now. Let's do this. Let's go to the K8s API file, and then we'll do var, and we'll say replicas equals flag dot int. Let's turn off Copilot real quick. Control Shift P. Disable Copilot completions. Did that actually disable Copilot completions? Or did they move it? Either way, I think I disabled completions. So we have replicas, and then we do... Oh, we did not disable Copilot completions. And then we pass the replica count there, and we'll do replicas int, right? And then instead of the replicas here, we have int 32 replicas. Cool. Let's see what happens if we build this. Oh, this is not actually the Go command failing. This is my shell prompt realizing that I have a Git repository without any commits in it, and it's very confused. Let's add WebAssembly binaries to the git ignore. There we go. So now we can do yoke takeoff example, and then we use the dash dash here to terminate yoke's command line flag parsing. And we could do dash dash help and successful takeoff of example. That should not have been successful. Flag.parse? Yeah, I did call flag.parse. Let's say dash dash help right here. Okay, usage of example.wasm, replicas int, number of replicas default 2. You know what? Let's pass it without that, and let's say with replicas equals 5. Successful takeoff of example, and then it creates 5 pods. 5 pods. I'm not sure what was going on there. Might be a bug. Either way, you see, we have 5 pods, and we're very lucky that all of the pods are on different machines. Does it support rolling release? Kubernetes does by default, but if you update a deployment with a new image, it will automatically roll. You know what? Let's show that off. One sec. Docker run rm it ubuntu latest. Grab a copy of Ubuntu. Watch echo hi. Okay, watch is part of the Ubuntu image. I saw both terminating a bit before, so was confused. Yeah, that's the deployment rolling out. So let's change this. Let's actually add let's add another flag here. We'll call it image equals flag.string image Alpine latest container image. Cool. And then we can add the star image here. Oh, --help did not do a 0 exit code. Yeah, I think --help does a 2 exit code. Let me double check. Go run. Let me just fix this compiler real quick. I'd expect it to do a exit with status 2. So then we do image string, save, and then we do cfg.image. Go run / Kate's API -- no help. Oh. Wait, what? Shouldn't it be exiting with exit code 2? Hold up. I feel like I did something wrong. Oh. Right. That's because it prints the help to standard error. And oh, it printed the help to standard error. That means it had nothing in standard out, which means that it parsed it as a YAML document that has 0 things in it. There is a weird issue here, so it's a nil slice of resources likely. Cool, we found a bug. Awesome. I am so happy to find bugs. Should there be such a safeguard against making such mistakes? Probably, but that's why we test stuff, because, you know, you're gonna mess things up. Let's run this. Okay, so I'm going to switch over to here, and as you can see, there's 5 pods here. So if I run this command, what we should see is all of those example pods will roll and be recreated as different pods with, you know, an age that isn't 4 minutes old. Hey, look, it did exactly what I thought it would. Oh, it's actually worse. It's doing crash loop backoff, error opening terminal, unknown. Perfect. It fails, but you get the point, right? Let's see what happens if I just change it back to Alpine. Oh, it just slays off the old pods. It slays off the new pods and uses the old pods. That makes sense. Cool. K9s, where did the extra 9 come from? Oh, K9s? Oh my goodness. K9s is probably one of the most useful Kubernetes tools ever made. K9s CLI.io. It is an interactive explorer of the Kubernetes API. Like, K9s is hands down the reason why I am able to put up with Kubernetes for my home lab. It is so good. It is so good. Because you just, like, let's say you want to look at services, So we look SVC, we see that there's a service that we defined 5 minutes ago called example, and there's one defined 6 days ago called Kubernetes, which is the local forward to the Kubernetes API. And like, yeah, it is so good. It is like honestly one of the best things ever made. By the way, you should update it. Yeah, I know. I need to update a lot of things. I need to update Homebrew at some point. I'm a coward. We can also pass the input as JSON to standard in or YAML or whatever. Desktop app equivalent would be OpenLens. Today I learned. Cool. This approach is similar to how Helm uses values.yaml to pass configuration, as using standard in is equivalent to passing a file. So we have our configuration type. In this case, it's just values. We have replicas, which is, a 32-bit integer that has a struct tag. In Go, struct tags are strings that get put at the end of struct fields that have instructions for reflection. Like in this case, we have an instruction for the JSON package that it should read the field replicas in the JSON to get the value for that struct field. So we have default values. We decode decode standard input as JSON, and then if it doesn't work, then you panic, which is equivalent to blowing up and dying. And then we have the deployment, and then we send the deployment to standard out. Then you can invoke it with inline JSON via the triple arrow, or read a file with the single arrow. Is there much static analysis for these tag things, type checked or anything? 1 second. There are linter rules that check things and make sure that it's correct. Most of it is ad hoc stringly type stuff, but there's a few things that are common enough that there's linter rules for it, so it's like realistically not an issue. It's also fairly easy to make your own linter rule for it if you need to. Cool. Let's take a look at the Helm compatibility bit. Although Yoke has the potential to change how we write Kubernetes packages, as of today and for the past 10 years, Kubernetes package management has been dominated by Helm. Yoke has no chance of succeeding if it cannot build off of Helm and provide a migration path forward. At its core, a Yoke flight is a piece of software that generates Kubernetes resources. In that way, a Helm chart is a subset of a Yoke flight. From that vantage point, our flight needs to accomplish two things to be compatible with Helm. Number one, embed a chart. And number two, render the chart with some values. At the time of writing, Yoke provides Go packages to accomplish the above items simply and easily. The reader is expected to be familiar with Go embedding. Oh, you're cheating, aren't you? Embedding a chart as a zipped archive. The Yoke Helm package supplies a function for creating a chart from its embedded archive. Suppose you wanted to use the Bitnami Redis chart from Yoke. The first step is to download the archive using Helm, and then you embed it into your application, invoking it using the name of the release, destination Kubernetes namespace, and any values you want to pass to it. Oh, this is beautiful. Oh, this is beautiful. This is absolutely beautiful. Like, okay, so let's actually just run this real quick, because what's going on here is really subtle, but I want you to understand what's going on here because I love it. So we'll make a new folder. We'll call it Redis. We'll go cd Redis. And then we'll run helm pull. Cool. Now, if we look in the Redis folder over here, we'll see that there's this Redis 2010.0 thing. So now I'm going to copy the file here, and we're going to go main.go. And then we're going to change this go embed thing here to point to the right file. In practice, you'd probably end up using a go embed file system. Go mod tidy. So if we look at the dependencies that we just downloaded, we downloaded Helm. Helm is written in Go. So in theory, there is nothing stopping you from invoking Helm inside Go, inside WebAssembly, inside Yoke. And that's what it does. So the run function loads the Helm chart from a zipped archive, and if it can't, then it blows up and dies. And then it gets the list of resources by rendering the Helm chart with the release and the namespace, and then values as a map string any. Values, or like a map string any in Go is kind of like a like just an object in JavaScript. It is a key value. A map is the like dictionary, and it's and the key is of type string, and the value is any, which is equivalent to every Go type, without being any Go type in particular. So with this, we're saying auth.enabled equals false. And then we render the resources to standard out. Let's try it. Go that, and then we'll say redis.wasm. It's building a bunch of stuff because Helm does a bunch of things under the hood. Okay, let's see how big the Redis things are. 78 megabytes of code. Yeah, that adds up. Kubernetes and Helm is a big, chonky boy. Like, Helm is a giant program. There's a lot going on there, so I'm not surprised that this is a fairly big WebAssembly blob. Then we just... gzip helps a lot. Try the gzip. Gzip redis.wasm. Let's add .star.gz to the git ignore. Oh, 13 megabytes. Yeah, that's way more reasonable. So now we'll do yoke takeoff redis.wasm.gz. To be noted, this is mostly useful during a progressive transition from a chart to a yoke-based code-based version of it. Yep. So let's run it. Ooh, we found a bug, but it might actually be that the Helm chart changed what they were doing. So what this is saying is failed to execute WebAssembly, failed to instantiate module closed with exit code 1. Standard error, failed to render chart, values don't meet specifications of the schema in the following types. Redis, auth.enabled, invalid type, expected boolean, given string. So what I did here is I changed the enabled from false in a string to boolean false. And that should probably make it work. I suspect that this is something that the Helm chart changed, and it's minor. Let's also add star.tgz. let's try rerunning this. Failed to apply resources. Dry run. Failed to resolve resource. No matches for kind pod disruption budget. I'm going to see if I can download the exact version of the Helm chart in the docs. My suspicion is that something changed in the Helm chart, and it is causing some weird issues. So let's see if we can just fix that. Interesting. I feel like this might be your Kubernetes cluster. This is code that tries to look up the resource mapping for policy. Okay. Let's try using a normal cluster because I'm using a V cluster right now just to like sandbox things. But let's YOLO. Kube context. All rest. I use kind for testing. Actually, kind cluster create. Kind create cluster. Let's see, yoke, is there's a yoke down or something. Ah, yeah, there is. Yoke down example slash example.wasm. Revision must be an integer ID. Oh, down is to go between revisions. You can delete with Mayday or delete. Okay. Oh, right. I just changed the Kubernetes context, so that won't work. There we go. And then we can do kube contexts to kind. Okay, so then we run the Redis by doing yoke takeoff Redis. And it's thinking. Yeah, I'm thinking it's the exact version of the Helm chart that's causing an issue. So what I'm going to do is I'm going to download and embed the version that you specified in your docs of 18.17.0. Don't worry, this is the kind of stuff that you discover all the time when you're like looking through documentation for the first time. It happens to everyone. Like I work on a developer tool, or not really a developer tool, but I work in marketing for like an object storage company, and we find issues like this in our docs all the time. It's just a fact of life. Okay, so let's run the Redis with the older version of the chart. Successful takeoff of Redis. Okay, I will paste the working command in there. I think Helm is checking the Kubernetes version when installing, and then in the chart, different versions of the object can be used. Yeah, that makes sense. Oh, there was an ad break that started without me realizing. Okay. So okay. While the ads were going, and I didn't realize, sorry, I figured out that it was actually the Redis chart that was the problem here. So I I am very thankful that the documentation had the version number of the Redis chart right here. And I used that to pull the exact version of the Redis chart that you were using when testing this. And I ran that, and that works. So my guess is that this code is actually fine. It's just some weird conflict between like how Yoke runs Helm and how that Helm chart got updated. Thanks for the follow, half in pink. But either way, like we got this working. And like this is a really elegant way to do it. Like I absolutely love the strategy of okay, you want Helm? You just embed Helm into your program and then you execute Helm like normal. That's just absolutely fantastic. I love that. I love that so much. Okay, let's read the rest of this. Progressive migration via chart file system embedding. Oh, that is the thing that I was saying about about this. Okay, cool. The advantage of embedding a zipped archive that it's simple to get started and use the chart. It's a great approach when you want to wrap just one chart or combine multiple charts into one yoke flight. The major problem is that we can't modify the chart. This is important when we want to port the logic out of the chart and into code. For this purpose, Yoke provides the ability to load a chart from an embedded file system. Continuing from our previous example, let's untar the archive. Okay, let's untar the archive. Okay, we have a bunch of files here. We should now have a directory called Redis containing the chart's contents. With a small tweak of our previous example, we can now use this folder to create our chart instance directly in our flight. The all prefix is important, otherwise Go will not embed hidden and private files. Today I learned. So let's go here, and then we have this. So Go has what are they? What's the right way to call them? Go has magic comments that aren't pragmas but are practically pragmas. And one of the pragmas you can use is go embed. Go embed is go embed. It's kind of like the include bytes macro in Rust, where you can embed the contents of a file from the file system into a variable in your Go code. But where Go differs is that it also lets you embed file system folders. So what we're doing here is we are embedding the Redis folder and everything in it so that we can like yeah, we're embedding the Redis folder and everything in it so that Helm can use it in code. So now instead of the chart being from an archive, we do chart error colon equals helm dot load chart from fs, and then we load it from chartfs. And it's going to complain and say there's no new variables on the left side because even though that code doesn't work, it's still somewhat valid. And there we go. And then we can do the go build command. Is it still a giant blob? It is. We can gzip it. And then we can run it and nothing should change. Results resources are the same as the previous revision, skipping takeoff. Perfect. Like, yeah, this is exactly what I wanted to see. I wanted to see nothing happen, and nothing happened. 10 out of 10, no notes. Generating flights from chart repos automatically. 1 second. Oh, this is beautiful. Embedding charts and rendering their contents via Yoke works well enough. Doing these steps by hand isn't a lot of work, but why not automate it? While we're at it, is there anything we can gain from an automated approach? Yoke provides a utility called Helm to Go. To install it, run this command. I'll install it real quick off camera. This utility is a wrapper over Helm for pulling charts. It requires Helm to be installed on your computer in your path. Bitnami's README generator for Helm, which converts a chart's values.yaml into a JSON schema file. And then Go JSON schema for converting JSON schema documents to Go types. Together, these tools allow us to generate flight packages directly from a chart URL. What? Oh my goodness, we need to try this. This looks cool. Let's do MongoDB. Oh my goodness. It's just automated. Okay, what did that do? Redis flights. It created a folder called flights, and it has the MongoDB tarball, and it has flight.go, which embeds the MongoDB tarball. Render chart renders the chart downloaded from the Docker, from the that you downloaded. And then it has all of the values in the MongoDB chart. And then we can use the generated MongoDB package to handle all of the boilerplate of instantiating and executing the chart, plus provide interred typings directly from the chart. Oh my goodness, that's gamery. That is beautiful. Ten out of 10. That's amazing. Okay, let's I'm gonna look at Yoke CD first, and then we're going to implement something actually useful. Yoke CD, GitOps, Yoke and Argo CD. The Yoke CLI is analogous to the Helm CLI. It is a client-side tool that communicates with your cluster and keeps track of packages deployed to it. However, for many, that is not how we deploy packages anymore. Where the words platform engineering are uttered, GitOps is sure to follow. To that end, we want to be able to write our flights and have a continuous deployment tool such as Argo CD manage our resources for us. Out of the box, Argo CD supports Helm, JSONet, and Kustomize. But to support more use cases, it accepts extensions via config management plugins. Yoke CD is the official Yoke config management plugin for Argo CD. It allows you to write Argo CD applications but have their source evaluated by Yoke's embedded WASM interpreter. The Yoke CD plugin supports a variety of setups. Invoke a local WASM binary found in the application source. Invoke a remote WASM binary downloaded from an HTTPS URL. Compile an application source on the fly and evaluate it using the Go toolchain. And configure any invocation of the binary with flags and standard input defined in the plugin's definition. To be compatible with Argo CD, Yoke offers an Argo CD CPM sidecar Docker image hosted at GitHub Container Registry. Installing Yoke CD sidecar. Fresh Argo CD installation. The Yoke project maintains a flight called Yoke CD installer that wraps the Argo CD chart version 7.7.16. The flight patches the Argo CD repo server by adding the Yoke CD sidecar to it, thus rendering the plugin available to Argo CD applications. To configure the Yoke CD installer, you can pass a YAML or JSON document over standard in. Okay, let's do this. This is cool as hell. This is about using Yoke with Argo CD. The air traffic controller is somewhat interesting if you ever don't want to mess with Argo CD. Oh. Let's look at air traffic controller. Air traffic controller is a Kubernetes controller that enables the creation of custom resource definitions and implements them through Yoke flights. The problem with current deployment tools: client-side package managers. Yoke introduces packages as code, shareable as WASM executables. However, client-side package managers are limited in Kubernetes environments. These tools fail outside of the Kubernetes APIs, they fail to track, these tools operate outside Kubernetes APIs, deploying resources ad hoc into clusters. They also fail to track package lifecycles effectively without reliance on resource labels or implementation-specific secrets. Such reliance on tool-specific implementations makes managing packages less transparent and harder to standardize. Tools like Argo CD rely on generic container resources, such as an Argo application, which is flexible but introduces a challenge. Users creating Argo applications can bypass organizational RBAC and assume Argo's deployment permissions. Argo applications are generic and pass unchecked values to their underlying resource renderer. Argo applications are deployed as generic resources, obscuring their types and requiring either labels or naming conventions to organize and filter them. The air traffic controller makes package management native to Kubernetes by defining packages as specific, well-structured resources. This approach uses Kubernetes features like OpenAPI validation for robust definitions, enforces RBAC policies, limiting resource deployment and enhancing security. By aligning with the native capabilities, you improve security, governance, and control over deployments. Okay. Air traffic control consists of two components: the air controller deployment and the airway custom resource definition. An airway is an API that enables you to define and connect two core elements: a CRD specification of your creation and its corresponding flight implementation, which is specified as a URL to a WASM executable flight. Air traffic control monitors airways and creates the specified CRD, spawns flight controllers within its process to manage the corresponding CRs. When the CR is created, updated, or modified, the relevant flight controller invokes the corresponding WASM flight to compute the desired state of your resources and apply the changes to the cluster. So it's like a standard Kubernetes operator. This allows you to define custom packages and enable users to deploy them as native Kubernetes resources. How to install the air traffic controller: namespace ATC, version latest, release ATC, URL is this base thing. Use the Yoke CLI to deploy the air traffic controller. Okay, let's see what breaks. Now is the time for you to be terrified, eh? So namespace is ATC, the version is latest, and the release is ATC. Let's see what breaks. Would be kind of nice if there was a like command line log message for we're running. Ooh, successful takeoff of air traffic control. That's a funny thing to say. Okay, so we're watching resources. Cool. Let's hit logs here and let's go back to StreamFox. We'll be following along with the example found on GitHub. I will close these tabs real quick. To begin, we'll need two things: the definition of our custom resource and a flight to implement our resource as a package. For the sake of our example, let's assume that for our enterprise, we wish to create a package representing a backend or API service. First, let's define a Go package containing our new custom resource type. Okay, so we make... we have backend. backend v1 backend.go. And we have package v1. We have we import the JSON package, we import string formatting, we import Kubernetes metadata, and our API version is examples.com, and our kind is backend. Oh, this is how you make it type safe, isn't it? Oh. So what this does... Oh. With this, we're going to be making a custom resource definition for the app type, and then have that get handled by a flight URL, so that way you can have your... this is how I'm going to implement this, isn't it? This is how I'm going to do it, because, like, I define, like, within website X example app, right? And I have options for, like, enable serving it over Tor or enable HTTPS. And if you enable HTTPS, what's the host name? Enable internal things for HTTPS and whatnot. Like, this is how you do it. Like, yeah, this is it. This is the thing. This is the thing. We have our backend specification, which has, like, the image you want to run, the number of replicas, the labels you set, the node port, the service port. You have the custom marshalling logic so that you inject the right kind and API version into the thing. You have custom unmarshalling to erase an error if the API version or kind doesn't match. Yeah, that makes sense. And then we want to implement a program to transform this resource into an array of resources. Nothing in our example implementation is specific to backends or any kind of workload. For this example, our package will output the backend as a Kubernetes deployment and service. This is fucking beautiful. Okay, so we have our flight, and our flight imports the Kubernetes apps namespace, it imports the core namespace and the metadata namespace, as well as some, like, helper utilities. We import our backend type, CRD, and main is func main. If run fails, then blow up. Hi, Doc Rect. I'm having my mind blown. What the hell is yoke? Quite possibly one of the best things I've seen in a while. Infrastructure as code, but actually, you define your Kubernetes resource as WebAssembly programs. This is stupidly convenient in practice. When this flight is invoked, the air traffic controller will pass the JSON representation of the backend instance to this program via standard input. I wouldn't call it a package manager for Kubernetes. I'd call it more like a... I don't know what to call it. ATC example.go. I'm going to paste this into VS Code real quick so that it's easier to read the comments. Something to probably fix in your documentation. It's not urgent. So here's our flight. We have this and run. When this flight is invoked, the air traffic controller will pass the JSON representation of the backend instance to this program as standard input. We can use the YAML to JSON decoder so that we can pass YAML definitions manually when testing for convenience. Okay, cool. So we pass the backend. You configure some sane defaults, like if you don't specify a port for the service, then you use port 3000. I hope they don't use template sliced YAML as language. No, that's the thing. It just uses whatever code you want. You can implement it in Rust, you can implement it in Go. All you have to do is output the resources to standard out, like WAS0 run example or cd dot dot. Like, for example, I have this example.wasm thing. Uh, it takes a second, but then it just outputs a bunch of Kubernetes resources. Like, yeah, it outputs an array of Kubernetes resources, and then that's what get applied. That's what gets applied. So, for what language it is, what language do you want to use? You want to write it in Rust? Cool. Just output JSON to standard output. You want to write it in Go? Cool. Output JSON to standard output. It's fucking incredible. So we configure some same defaults, like the service port is there, and make sure that the labels include the custom selector, which is like, I don't know, like an app name or something embedded by default. The way it's just a pipe into kubectl or something, basically. Except it's a bit more ornate than that. I'm like very much summarizing this over. Look over the VOD, and you'll probably see a bit more of the cool. AMD 64 ASM to output JSON into Yoke. Yeah, you could do it. Can't wait to handcraft a WASM binary that outputs kates.json. It's all statically linked. There's no shelling out. Okay. Oh, you implemented the kubectl apply logic? I was looking at implementing that at one point for Yeet, but that was such a pain in the ass. Oh, this is cool as hell. Go mod tidy. So we create a deployment, which has all the deployment guff. We set an environment variable with the service port, and then we expose the service port to there. That makes sense. We create a service that points to the service port, or that points port 80 to the service port. Which, yeah, that makes sense. That's a good opinionated default. And then there's this selector function which will take the backend type and then output default labels. Absolutely fantastic. I love this example. I love this so much. Let's see how this works. How are you? I'm doing pretty good. I've had a kind of boring week. I've been writing some conference talks for next week because I'm giving 2 conference talks in a week. I'm going to be flying to Rochester on Wednesday and then flying from Rochester to LA to Los Angeles on Friday and then flying back to Ottawa on Sunday. It's going to be hell. But I'll survive. It tracks the releases with the own label, kind of like Helm does, which is not something that kubectl apply can do. I wish I had a boring week. Yeah, me too, fam. Why? Oh my goodness! I just looked at the labels for the air traffic controller thing, and because it was deployed by Yoke, we can see that the Yoke CD app is ATC, and the Yoke dependency hash is that, and that's how it can keep track of stuff. Oh, that's beautiful. Okay, the flight executable can now be built with the Go toolchain. Where and how you choose to host this binary such that it's fetchable by the air traffic controller is up to you. Common choices include GitHub releases, internal services in your cluster, any service that hosts assets for you and allows you to fetch them over HTTP or HTTPS, like object storage. Since we're following the example from the Yoke CD examples repository, we'll be using the latest example of this flight. Now all that's left is to build an airway using our v1 backend type in conjunction with our flight. Let's define it in code. So we have the API extensions, the Kubernetes metadata, the airway type, the OpenAPI stuff in Yoke, and the air traffic control backend type. My splitter, USB charger, and overpriced gaming laptop all broke down. Oh, F. Oh, that sucks. Okay, so what this flight does is we create in a V1 Alpha 1 airway, and its name is backends.examples.com. Its spec is that we download the URL from here. We create the examples.com group. We create a backend with the backends for the plural and backend for singular. BE is the short name, and the kind name is backend. Its scope is a namespace. It's a namespace scoped type, and it is version 1 of the custom resource definition. And its OpenAPI schema is the is automatically generated with reflection. Cool. With this final piece, we have built a flight that installs the airway that'll bind our resource to its implementing flight. Fortunately, for the rest of example, it's also hosted in the GitHub releases of our examples repository. Putting it all together, let's install Yoke, set up a local cluster, install the air traffic controller, install our airway, and finally our new backend component. You know what? Let's do it. Let's delete the cluster and recreate it. Let's follow exactly what this is doing. Okay, kind delete cluster and kind create cluster. What this is going to do is it's going to use kind or Kubernetes in Docker to delete the current kind cluster and create a new one. Kind clusters are super ephemeral by nature, so, like, I just created this cluster. It doesn't matter. We can blow it away. Cool. And then we'll install the air traffic controller by pasting this. So, yoke takeoff, wait 30 seconds, create namespace. The namespace is named ATC. The release name is ATC. And we download the air traffic controller installer. It takes a second. Again, it would be nice to have some debug logging that it's downloading and executing stuff. Yeah, this takes 10 to 15 seconds. Dash debug. Oh, okay. Cool. Let's add dash debug to this command and see what happens. So the next command is yoke takeoff dash debug. Wait up to 30 seconds. We create our backend airway, and that points to the flight that has the backend type in it. Oh, okay. So we load the WASM in like half a second. We compile it in about a second. We start executing it. We look up the resource mappings. We get the revisions. Then we apply the resource. We apply the CRD. We wait for them to become ready. And we have a successful takeoff. Sweet. You are done. You can now create backends. Okay, I'm going to open K9s, and we're gonna look at we're gonna look at the logs for the ATC actually. So what this last command does here in the bottom is we have kubectl apply -f dash, which means read from standard input, or read from the file name dash, which conventionally means read from standard input. We create an API, we create a backend in examples.com/v1. Its name is Nginx, and its specification is that it uses the Nginx image, has 2 replicas, listens on port 3000, and gets port 80 exposed. Cool, let's try. Oh my goodness, it just did it. Let's... And then we have Nginx. It's great. That's amazing. I love that. 1 second. How long have I been muted? Did I do that thing again? Oh my goodness. I muted myself to cough, and then I forgot to unmute myself, so I sound like a fucking psycho. I look like a fucking psycho. Couple seconds, probably. Okay. So, we look at the back end. We have an Nginx backend. I hit Y and K9s, and then I can see the YAML. And we have the spec that we defined that it's running Nginx with 2 replicas. Your CRD becomes a first-class citizen in your cluster instead of a Helm second-class release. This is freaking awesome. And what I can do is I can just, hit E, then go down here, and then say I want 3 replicae, and then, you go over here, you go to your default, and bam, there's a 3rd replica. You people have created the tool that I've wanted to exist. Like, this is what I've wanted to have. This is it. This is the thing that I've wanted. This is it. This is like the thing. This is the thing that I've wanted. This is so good. Like, this is so good. I don't even know where to begin because like this is just fantastic. God, I love this. Okay, let's. I accidentally hit something on the table of contents. That's on me. Okay, flight overrides. Generally, the custom resources we create do not expose the flight implementation details. Users can create resources without being aware of how any of this works. However, this abstraction can pose challenges during flight development, as airways only accept a single flight module URL. Any changes to the flight implementation will update all custom resources associated with that airway. During flight development, you may want to test a new implementation in production with a non-critical application as a canary. To enable resource-specific flight implementation updates, you can override the flight URL using the following annotation: overrides.yoke.cd/flight:\URL. The air traffic controller will use the module located at the specified URL and apply it to the custom resource. For example, you can add the implementation as shown. The development module is not cached, as it is assumed to be neither stable nor versioned. This allows you to iterate on the module by updating its source without changing the URL. This means that overrides are not recommended for production use. They're significantly less performant than standard modules because each update forces the air traffic controller to download and compile the WASM module. Oh, you pre-compile the WASM module when you create the CRD? Oh. Oh, okay. So, like, oh, that is gamery. Oh, that's beautiful. Oh. Oh, I love this. That's why it's so fast. Oh. Okay. Oh. Conversion webhooks. Airways describe the custom resource definition you wish to create. It is recommended to follow the best practice outlined in official Kubernetes documentation. Avoid breaking changes and use conversion webhooks to translate between different versions of your custom resource. Setting up your own custom webhook server and deploying it to support breaking changes for your APIs can be cumbersome. To simplify the process of evolving your airways and APIs over time, the air traffic controller supports conversion webhooks for airways that specify a converter WASM executable. That's amazing. A converter program reads a conversion review object as described in this documentation, and then from standard input, and then writes the resulting conversion review with the conversion response populated back to standard output. An example conversion program written in Go can be found within the Yoke project here. Oh, this is perfect. Thank you for stopping me from looking at the Argo stuff, because this is like, this is the thing. This is the thing. This is the. These docs need to get fleshed out. Yeah, they do, but like, honestly, your docs are good enough that I'm able to understand everything that's going on without having to dig into the source code. And that is a bar that sounds really low, but I used to be an expert in Nix. My bar is below the Mariana's Trench. And, like, the fact that I can just look at all this, understand how everything works, and yeah, your docs are way better than you think. All you're really missing is polish. You have all of the all of the hard stuff right. You just need to, do the other 80% of writing docs. This is the first 80% of writing docs, like getting the concepts out, getting the imparting the important parts to people, and the rest is just like polishing it. Like, for example, it would be nice to have an example of when you want to use a list of lists of resources, because I personally know that you actually, what would be really funny? What would be really funny is having the air traffic controller thing, this entire example being a single yoke invocation that installs the air traffic controller, the airway, and then the backend. That would be funny. Like, that would be a great way to demonstrate how you would want to use a list of lists of resources. Totally possible. Yeah. Like, the thing is, also check out the example repo. Okay, let's check out the example repo. Flights. I think there are more steps that haven't made it to the docs. Yeah. Oh, I need to make these a little bit bigger. So this is an example of the Airway V2, and you have, the converter. Yeah, that makes sense. Script.sh. Oh. Install yoke CLI. Go install that. We delete the local cluster. We create the cluster with some config. That's fine. We install the air traffic controller. You install the backend airway. You're done. You can create backends, so you create that. You update the backend airway to use the V2 version. And now you can create V2 versions. It has the conversion webhook stuff I haven't finished writing into the main docs. Yeah. 10 out of 10. There's a lot of good stuff here. And so now let's get into the fun part of it. Let's make my own CRD, and let's fail at it horribly while we're doing it. So we're gonna start by making. Actually, you know what? I just wish the command line options were standard. That's why you use the air traffic controller, because then you define all of the options as Kubernetes resources, so that you get Kubernetes type safety. That's it. That's the thing. That's the thing that makes this goated, in my opinion. So let's call it within website app, and we'll make a new folder called v1, and we'll make a new file, and what did the example code call it? Oh, there's no option for dash dash context? Oh, right. I am in Windows. I can't use Control W. Ah, it looks like there isn't a way to do to pass a Kubernetes context in the command line. It's something that can be fixed. There is no dash dash anything. This is using the Go flag package, and that allows you to use dash dash. Uh, Probably worth noting somewhere. Like yoke takeoff, and then dash dash debug. But yeah, like, it's fine. Okay, so let's make within website app slash v1, and we'll call it new file app.go. We'll paste this as an example, and then we'll do x.within.website, and then we'll have the kind app. We'll change this to kind app. And then we'll do kind app. We're writing a Kubernetes custom resource for me to deploy applications in my home lab. I always like to specify the context on the command so I don't put stuff on the wrong cluster no matter the current one. Valid. Valid. That's incredibly valid. Off camera, I'm pulling up an example of like what I need accepting PRs. Yeah. It's like a lot of this stuff is just like low hanging fruit. It is stuff that just can be fixed. It's fine. So then we have backend is the type representing your custom resource. Then we'll change this to app. App represents a backend application with a specified image, replicas, labels, serve it with opinionated defaults. Did I misspell opinionated? Spelling. O-P-I-N... O-P... How do you spell opinionated? Oh, I am just failing at English, my native language, because why wouldn't I? That's what you do. You just fail speaking English. So app 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 app. English hard. Yeah, English the hardest. And then we do app, 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 app. Why not use F2 to rename stuff? Because that would imply that I know how to use VS Code. Let me just look at an example of a simple app in my cluster. Oh, there's the stickers over here. Cool. So we go down here, and what are the things that we want to specify? Let's do auto update bool. JSON auto update omit empty. Let's say like, oh, did the music stop? Oh, it did. That's why it was so quiet. What is the name of the Kubernetes type for like resources? We'll add this later. Resources. Show VS Code again. We'll have it not run as root by default. Type help. Oh wait, I tried to hide the Firefox and I showed it. I'm smart. Path, port, and then health check, health check. Log level. Port int. Ingress, ingress. And then we'll do type ingress, host string, then enabled, and host. Is there anything else I need to customize in ingresses? No. Ah, we need the cluster issuer. If I.enabled and that, then that's going to be that I.cluster issuer equals let's encrypt prod. Cool. Thank you, Copilot. Is there anything else that needs to be there? Like, we can do the ingress class name. Class name and by default it just defaults to Nginx because that makes sense. Yeah, that's fine. We have. I'll figure out how to do the 1Password CRD later. That's something to add there. Okay, cool. So we have our app spec and we have our health check. Awesome. in the sauceum. Cool. We have our CRD, and now let's look over the docs again and see how you apply a CRD. Um, right, we have to make our flight for deploying the individual things. So let's call this flight, or yeah, let's call this flight. Hide Streamfox for a sec. Folder flight. New file, main.go. Paste. That's fine. And then the package where we defined our backend type. Cool. And then that's going to be yoke stuff / within website app v1. You want two things. Flight implementation, airway that wraps flight, URL, CRD definition. Yep. Okay. Or var app is a v1.app. App. And what did we call this? We just called it port. Default of 3000 if it's not there. And then we go down here and we change it to how my other things declare the labels, which is using the full formal app.kubernetes.io/name label. Yeah. Okay, where is it blowing up? Port. Okay, cool. Now let's see where else this is blowing up. Oh. We always want the type to be a cluster IP, because that's the opinion that I have. Node port services are the devil. The name should be HTTP. This is exactly why we want typesfd /editor time error /type hints. Yeah. So much easier to fix stuff ahead of even trying it out. Yeah. Like, yeah. I am totally down with this sickness. Like, okay. So I made the text a bit smaller. You're gonna have a small issue down the road. Your cluster needs access to your flight via URL. You can host it on GitHub or equivalent. I am gonna be hosting it on my Minio server via a public bucket that I use for random stuff like this. So don't worry. I know I'm gonna hit that landmine, and everything is going according to Keikaku. Translator note: Keikaku means plan. Okay, and I guess we also want to default to the replica count being 1. So then we're gonna have var results and slice of any results equals append, create deployment, create service, if app.spec.ingress.enabled. We append the create ingress we append the results to the create ingress function, but that doesn't exist yet, so that's going to be fine. And then image pull policy core v1.pull if not present. I want pull always. The security context is going to be and core v1 dot pod security context, and we want file system group to be pointer dot to 1000. Oh. We want a pointer to int64. Right. It's a generic function. Right. Okay. Yeah, that's going to fail because the ingress doesn't exist. That's fine. And we want security context, core v1.security context, run as user, pointer dot to int64 1000. We want to run as group. That run as non-root is a pointer dot to bool true. Allow privilege escalation, pointer to bool false. Capabilities is the core v1.capabilities. And we want drop all. We want seccomp profile to be the runtime default. No, that's not there. Seccomp profile type runtime default. Okay. Result colon equals that, and then return result. If the health check is enabled, then results.spec.template.spec.containers sub0 dot liveness probe is a core v1.probe h okay. Isn't this so much more fun than writing Helm templates? Yeah, like obviously this is a bit taking a bit longer than it would if I was using a Helm template, but I'm making this super generic. We want our initial delay seconds to be 3. We want our period seconds to be 10. That's fine. Handler is the HTTP GET, and the path is backend dot spec dot health check dot path, and otherwise we get and then we get the port, and we get that, and then that's going to be grammatically invalid because why wouldn't it be? Oh, probe handler. Oh, that worked. HTTP headers is a core v1.http header, and then that name is x Kubernetes, and then value is kinda okay. And then also for environment, we add name. Oh yeah, we add slog level, and that's the value. Compare.or, spec.log level, or info. Yeah, that makes sense. That's a good default. And then we'll have name bind value format.sprintf colon that. There we go. Now let's look at here and what else I did. We have auto update and if backend.spec.auto update result dot annotations equals map string string, and then we'll add the Keil annotations. Keil.sh/policy all, Keil.sh/trigger all, Keil.sh/poll schedule is at hourly. I remember seeing a function that like merges maps. Maps.copy. Yeah, let's do maps.copy. Oh, it returns. It doesn't return anything. Okay. Goes a bit verbose for literals. Would be curious to see the equivalent literals in TypeScript. I guess we can get the same type Kubernetes API definitions in TypeScript somehow. I'd love to see Rust. I think the Rust version would be really, really, really elegant. So then we can do func create ingress, and we need networking v1. I love Copilot sometimes. It's just so good. It's an annoying little fucker. Like, I won't deny that, but oh. You know what? Let's not have Copilot define all that for us. Let's leave something to us. Ingress class name is that, and then TLS is networking v1.ingress TLS. That's fine. And then let's just make the language server happy. Okay, result colon equals that. Ingress class name has to be a pointer, so ptr.to string that. And then the TLS rule, so we have hosts is that. Secret name is func mk TLS secret name, and that will be backend v1.app. And then we're going to make this public TLS, and we're actually going to be using the host name, but strings.replace all in backend.spec ingress.host to dash make TLS secret name for backend. We need to call this app. There. We can omit this type argument. Okay, now we define the rules for a slice of ingress rule, and the host, or no, we define an individual rule, and host is going to be a string, yeah, and it's going to be the ingress host. Let's pull up the ingress rule docs in here real quick. So we have the host and we have the ingress rule value. Okay. And then we have HTTP, we have paths, empty thing, empty thing, empty thing. And we want path type prefix. Is that we want a pointer to that? That's fine. And path is slash, and the backend is probably that. Yeah, the service is probably that. Probably that. Port, and then we're going to want the name HTTP. Ingress service backend. And that is a service backend port. The name is HTTP. Okay. And then now we have everything done. Like, okay, so what this is doing is we... do we have all the stuff in there? Okay, so our app spec is that our thing has an image. Let's remove these type arguments because they're irrelevant. So when this flight is invoked, the air traffic controller will pass the JSON representation of the backend instance of this program via standard input. We can use the YAML JSON decoder so we can pass YAML definitions manually when testing for convenience. Okay, cool. So let's write our own example CRD. So we CD within website app there, and then we do code, let's say sticker. Is that going to work without any configuration? I don't think so. What else would be in here that would work without configuration? Oh, Anubis. Anubis.yaml. No, wait, Anubis does need a backend. Let's do Uncle Ted. Okay, so then we're going to have API version x.within.website /v1 kind app, right? And then we have metadata name Uncle Ted, labels test app, please ignore. Cool. Spec image ghcr.io/z/x/uncle Ted replicas 1 labels. Oh, wait, I don't have to specify labels here. I can just specify labels on the app and have that get percolated down, right? Yeah. 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 Label, percolate the labels down here. Percolate the labels down here. Yeah, that's how you do it. That makes sense. Okay, so now we do go export goose equals cp1 gorch equals wasm. Go build v1 flight. Go build -o x app.wasm. Delete that. Then we can do yoke up dry run dot uncle ted dot slash xapp.wasm input from uncleted.yaml. Oh, it's -dry. Successful dry run takeoff. Oh, right. I want --standard out. Okay, it's not making an ingress because I did not tell it to make an ingress. Perfect. It's puts a port, go to port 3000, we bind on port 3000, we have our log level set to info. Yeah, this is what I want. Auto update true. And then we want ingress enabled true, host Uncle Ted dot within dot website, and those defaults are sane. So if we panic, assignment to entry in nil map. Ooh, that's a fun one. Maps.copy on if result on annotations is nil. Yeah. So why this this failed because I said auto update equals true. Oh, at this run you can test directly with go run. Oh, right. Go run /v1/flight input from uncleted.yaml. Oh, right. I set the default go arch and whatever to that. It's fine. I'll just. So the reason why it crashed is because result.annotations didn't exist. I control the code, so what we can do is we can just make result.annotations exist. So then we have annotations is map string. Thanks for the follow, Teddington UK. Okay, so we have we need to jake this. Where's the ingress? Why aren't you making the ingress? Did I typo it? I did not. Okay, is this actually getting to the point where it is actually decoding the ingress. Okay, cool. But why aren't you putting it to the list? Ingress enabled equals false. That doesn't sound like what I said. Ingress enabled true. Let's try adding the YAML tags just in case. It shouldn't matter, but it might. No, why aren't you doing that? Is there some Kubernetes thing I'm missing here? I feel like I'm doing something obviously incorrect. Uh, Nil pointer dereference on line 152 of flight.go. There is something very obviously wrong that I'm doing here. This kind of reminds me of the K3S Helm controller. Yeah, kinda. That's actually a good comparator here. K3S Helm controller is really nice. Okay, what am I doing wrong? Um, if app.spec.ingress not equals nil, and that, then there's got to be something wrong I'm doing here. Yeah, it's simply not loading the things. Hold on, let's YAML is saved? Yes, the YAML is saved. Cat uncle ted.yaml. The ingress should be there. Hi, Sophony. Welcome to the stream. I am failing at Kubernetes right now. Thanks for the follow, Sophony. Yeah, because this is saying that you just, like, define stuff and it's fine. This all has omit empty. Oh, I know nothing about Kubernetes. It's too abstract for me. I want to learn it. It's not actually that hard. It's just weird. Like, Kubernetes is just a database of descriptions of what you want, and then some controllers that will automatically make that state of the world reality. Like, literally, that's it. That's all Kubernetes is. Yeah, see? New folder. Let's make a airway folder. And let's go main.go. I'm doing some pretty, like, out there infrastructure as code stuff, but even then, like, it's not that hard. It's just different. Let's just assume that this is right for now. It's one sec. Fuck. Let's assume that this is right for now. It's not, but like we'll fix it later. It's probably something really dumb. So export AWS profile equals what did I call it in here? Cat tilde slash dot AWS slash config all rest. All rest AWS S3 LS. AWS S3 CP X dot slash X app dot wasm or gzip X app dot wasm AWS S3 CP dot slash X app dot wasm dot gz S3 colon slash slash me static slash yoke slash X app dot wasm dot gz X app slash v1 dot wasm dot gz curl head https minio dot zserv dot us slash static yoke x app v1 dot wasm dot gz. Perfect. We have a URL. We have a WASM handler, and then the API group is going to be x.within.website. The plural is going to be apps. The singular is going to be app. The short names, we don't need a short name. The kind is app. And our open API schema is going to be v1.app. Perfect. Then we can do go run slash v1 slash airway. Oh, right. Go run slash v1 slash airway. And then that gets that in there. Cool. Okay, so yeah. Oh, let's try and run it. Omit empty, emit zero, and pointers or how values are interpreted is optional. If not, they are required in the open API schema. Yeah. Let's go for it. Let's deploy this thing. So then we're going to want to do... looking over here. Go build dash o x app airway dot wasm v1 dot slash v airway gzip x app airway dot wasm aws s3 cp. We put that in the airway, and then we can do the super gamer move. Yoke take off dash wait 30 seconds app airway, and then airway v1.wasm.gz. Let's break everything. X.value.within.website must be spec.names.plural plus spec.group. Oh, I fucked it up. Apps.x.within.website. We build the airway. We copy the, we build the airway. We gzip the airway. We copy it over. And then we take off again. Oh my goodness, that worked. We have apps. And then if we go down to the air traffic controller, we see that we've done it. We are watching resources of type app. Kube cuddle apply dash f Uncle Ted. And it just instantly goes. That's amazing. Yeah, and the ingress isn't working there either. Okay, I'm probably doing something really wrong. You can even see the backends and canines. Yep. If I do apps, we see Uncle Ted. And oh, it is actually recording that the ingress is enabled there, but it's just not percolating out. The logs aren't being shown. That's annoying. It's your flight implementation as a bug like in local, yeah. Let me read that flight overrides, and then we can override Uncle Ted. Yeah, I'm just not sure what the bug is, because, like, this should not be bugging out. I'm doing something very, very obviously wrong here, and I'm gonna feel like an idiot when I figure out what it is. So be prepared for me to say that I'm an absolute baka. Uh, let's make sure there was no typos in the struct tags. You know what? That's the stupidest possible thing that it could be, so let's just check it. Kate's API, no. Airway, no. Flight, yes. No, app.go, right. Okay, so my app spec has an image. My app spec has replicas. My app spec has a port, but it defaults to 3000 if you don't set a port, and there's an ad coming in 21 seconds. Let's sort these. Okay, so wait, is it getting the health check either? Let's see if it's getting the health check. Um okay. So go no, that's the broken terminal. Go run v1 flight input to Uncle Ted. No, that's working. Does Uncle Ted have a slash handler? It does not. What? No. Why did that work? Oh, because I had a health check to find in there. The app spec ingress is not nil, and the app spec ingress is there, then is it because I don't have all the fields set? No, it's not because I don't have all the fields set. What the hell? Okay, let's rename this to HTTP. Ah, that's gonna... No, that... Why the fuck are you not working? Oh. No, that still is not working. Okay. Wait, did I... Thanks for the follow, Sylphid Games. Okay, you know what? We're going to, we're gonna fix this. Okay, and then... We're gonna make a new struct. I think I did something wrong. HTTP star HTTP. And then we will type HTTP struct enabled bool host string got a drop for dinner. Great job tiring out Yoke Live. Yeah, have a good dinner. Yeah, seriously, this is a great tool. Like, as frustrated as I am at being bad at programming right now, this is an amazing achievement. Like, what's going wrong right now is a me thing. I am being a baka. A pointer receiver in the... Oh my goodness. Is it really that dumb? It is. Oh my god, you're totally right. Oh my goodness. Not sure if that will help, but I feel like that's where we're at. I am almost certain that that is what it is going to be. It was the pointer receiver. Oh my god. Oh my god. I I keep telling people when you're debugging stuff, It's always going to be the stupid thing. Like, you're going to make an error, and it is going to be the absolute dumbest possible thing that it could possibly be. And when you finally figure out what it is, you're going to feel like an absolute fucking moron. And I feel like a moron right now. So, let's... right. Uncle Ted overrides it, so... Okay, we copied that there, and then we kubectl delete Uncle Ted, and then we kubectl apply Uncle Ted. We disable the health check for now. We close these two things real quick. Default Uncle Ted exists for 5 seconds. Ingress Uncle Ted. And yeah, that was it. That was it. That was the thing. That was the thing. I swear, it's always the stupid thing. Like, okay, so what was going on here is a subtle Go thing, and I feel like I need to, like, confess what I did wrong. So, in Go, there's two types of values. There's normal values, and there's pointers to values. Normal values are copied between function calls. So, like, if you had a this is a receiver. This allows you to make methods on a type. But under the hood, a receiver is just the first argument to the function. So by making ingress, by taking a non-pointer receiver of, I ingress, and making changes to it, and then not returning it at the end, I am making changes to it in memory, and then those could happen to a copy and get discarded. The solution is to make this a pointer to ingress so that I am actually changing values on the thing. It's a really dumb way to mess it up. It's always the dumb thing. Like, whenever you're debugging stuff, the longer that it takes, the more likely you're about to learn that you have made the stupidest error possible. And I did. Like, I'm not afraid to admit that I just made a massive mistake. Self-forgiveness is key. I mean, like, this is something that happens constantly in there. Like, one of the goals of what I do when I stream is I want to give people the experience of what it feels like to actually do, like, DevOps or programming or SRE, where there's a lot of moving parts, there's a lot of stuff going on, and you end up making a trivial mistake that ends up wasting your time. And it's not your fault that you made that trivial mistake. Sometimes it just happens. Like, sometimes it just works out like that, and that's fine. It's really annoying when it ends up biting you, but this is just what happens. Let's do build.sh. So then shebang / user bin. Oh, I should make the text a bit bigger. Export go s equals WASI p1. Export go arch equals WASM. Bye, Sylphid. Yeah. Stay safe, yo. So, what are the commands I was doing? Let's build the flight, and then let's build the airway. gzip star dot wasm gzip dash f star dot wasm. Yeah, that's a good one. Gzip dash f star dot wasm. Yeah. Case in point, I took 10 days to realize I mistyped a header while testing, while convincing myself that the partners were doing something wrong. Yep. It's always the dumb thing. We do that, and then we copy this to there, and then we copy that to there. Xapp airway v1.wasm.gz, and then yoke delete. Yoke up. I spent 4 days debugging the wrong Lambda because the names were similar. I'll be presenting the project at CNCF Montreal meetup in March. I'd almost rather you present for me. Oh, I'm doing so many talks lately, man. Oh, I got all the... I got it. I think I found a bug in flight control, but I don't know if it's a bug or a skill issue. The TLDR is that if you delete stuff, if you delete a airway, it doesn't delete all the resources managed by that airway. So what I did is I... Yeah. Yeah. Okay, then I got it. Perfect. That's not a bug, it's an indecision. Fair enough. It's probably correct to do it and apply the resource ownership rules properly. I wasn't sure if it was too destructive. I mean, I'm not sure if it's too destructive either, but like when I was just doing that, my expectation was that everything would get deleted. Like that is kind of destructive, but like actually, how does like cert manager handle getting uninstalled? Or most Kubernetes operators don't really assume that they can be uninstalled, do they? I can make arguments in both sides at this point. That's actually a really complicated thing. That's a good argument to have with someone. If you ask it to delete something, should it automatically delete everything or what? Oh, that's a good one. Okay, let's add one password operator to this. Go get that. Yeah. Then we go back to VS Code. Okay, and then we have the secrets type down here. Type secret struct, name that, and then we don't want key here. What we want is one password ID. And what is in a 1Password secret? Go to the kube folder, go to Eakis, go to X, stickers, 1Password. Item. Item path. And now here is the part where this can get fun. So then we can do environment, bool, and if true, set the contents of the secret as an environment variable. File system bool as a file in the file, set the contents or flag folder. If true, set each file as a file. Set each value in the secret as a file in a folder. Let's just call this folder. Awesome. And then if we go to the flight, we can go up here and for underscore sec colon equals range create 1Password secret. Nope, it's going to be, we're going to go to the top of this and we're going to import the 1Password stuff as API v1, and we're going to call it 1Password v1. And that's going to be Angie because 1Password v1 dot 1Password item. Yeah. And then result colon equals 1Password v1 dot 1Password item return result. Okay, and then we compare this with documentation. Okay, and then we get the type metadata and the object metadata. That's going to be incorrect, but and then this is going to be on password v1 dot group version dot group dot identifier. Yeah. Object meta is gonna be Annotations is map string string. And then it's going to be spec is a 1Password item spec. And item path is going to be sec.item_path. No, the name is not the app.name. The name is sec.name. Awesome in the sauceum. Okay, what else can a 1Password item spec contain? Just the item path. Okay, that's fine. So now we have 1Password secrets, and we have to handle all of them here. So then we do for underscore sec in the background if sec dot environment if not sec dot environment and not sec dot folder. No, we're going to have to add some assertion there at some point. If sec dot environment no, what is it in the deployment? It is n from result dot n dot spec dot template dot spec dot containers 0 dot n from equals append. You append it to the secret ref. Yeah. If there's a folder, then I think that may actually be it, but we don't want to put that in there. What we want to put it in is the file system in this place that flag folder looks for. So I go down to me, because I know that has a bunch of that stuff. Run secrets. Run secrets. Sec.name. Oh, wait. Yeah. Yeah. That'll do it. Oh, this is so nice. Okay, so then what we can do is bash build.sh go mod tidy set-euo pipe fail. Awesome. And then we can yoke delete app airway, or yoke delete. We first delete Uncle Ted. Then we delete the app airway. Then we up it. And if we go over here and we do CRD, And we go down here. We will see. Why are you deleting it before recreating it? Oh, that's a good point. No, I'm deleting it so that it uncaches the thing. We have the secrets in there. Sweet. If you update it, it will rebuild the WASM module. Okay, cool. Good to know. If it doesn't check if the URL changes, just airway on airway updates, it does the thing. Okay, perfect. I thought it was smarter than it is. My bad. Then we apply Uncle Ted. Uncle Ted doesn't have any secrets, but that's fine. Didn't know there was infrastructure as code using Go. Is it Terraform or something? No, it's Yoke. I will link you Yoke in the chat because this is like seriously one of the coolest things I've played with in years. Love this. Okay, let's test it on the main cluster. We're putting this into prod. Okay, and then K9s, we make this a bit smaller so we can see everything. We go to the deployments, and we deploy the air traffic controller. Air traffic controller is there. Talos is complaining, that's fine. We have thing, and then we're gonna make a more productive app. We're going to make stickers. Then copy, paste. What are you working on, by the way? Sumilez asks, what are you working on, by the way? I am making an easier way for me to deploy stuff by using custom resource definitions. So what I'm doing right now is I'm pulling some stuff outside of a different file, and I'm defining all the things in this. I'm defining all the things in here, and then I have stickers. So I have an app, and yeah, I have an app, and then it is the name stickers. It has this Docker image. There's only one replica. I want it to automatically update when things change. And now I'm going to add secrets to it. And then we have the secrets, and we'll call this name. So it's called, right? Name? Yeah, name. Tigris creds. There's also the world in which you can write all your apps and so on and define them in Go instead of use YAML. However, there's a point where YAML is easier to go into a really abstracted easy version, but you could be in the code the whole way if you wanted. Yeah, I figure once I get to the point where I have an app, that's the good stopping point for like where the infrastructure as code should end, because otherwise, because like right here, this is fine. I have the stuff, I have the stuff defined, and the rest is just configuration. Heck, one sec. So then we have environment true, and if we no, stop it. Go run dot slash v1 slash flight input from stickers.yaml. That should work. Oh, I love this. Let's just double check and make sure that this is doing what I want it to do. Pull the environment from Tiger's Creds. Ah, yes. Actually, you know what? Let's name the secrets a bit more generically so that we don't have conflicts. So we're going to call this format.sprintf %s dash %s, and it's going to be flight dot release and sec.name. In code, you have the types and IntelliSense as comments. However, you're right. This is a good line in the sand. This is not stuff you would test. Yep. And if I do test, it would be behavioral tests, not, like... Yeah. Whoa, you can have SSH sessions in a VS Code window? Yeah. Server could not find the requested resource. No resources found in default namespace. Okay, it is actually working then. So then K9s and NS. Oh, it was probably something that didn't get cached right. So if we go down to the default namespace, and then we go down to stickers.yaml, invalid value x.within.website.app.default.stickers tigers creds. Oops. There's me being a dummy. Let's fix that. Let's use this annotation real quick, and then we'll paste that there. And we will fix the flight, and it will be app.name. We run build.sh, and we reapply. Right, resource is the same. So then we apply the stickers.yaml. We created an app. The container is creating. Oh, this is awesome. This is cool as hell. And then I guess from here, what I need to do is create the PVC and whatnot, eh? Yeah. Create container configure. Ooh, that's a fun one. Why is there a create container configure? D. Secret Tiger's Cred's not found. Because I messed it up. Okay. Kubectl delete. That's awesome. It's like a super template, man. This is awesome. This is cool as hell. YokeATC. Oh. Oh, that's fun. Uh we'll put that on the main terminal in a sec. But oh, that's fun. Oh, I love this. Okay. Yeah, and then name. Bam, bam, bam. Okay, and then we run build.sh. We reapply. We run this, and now we will not get a container config error this time. Man, you're right. The caching really does do a lot to make this feel snappy. Oh my goodness, did this actually work? Oh my goodness, I think it worked. We have to wait for the DNS to propagate, I think. Yeah. Just restart the external DNS controller to make it go faster. Why aren't you doing the thing? YokeATC view could be fun here. Yeah, the thing that I'm trying to figure out is why I am bad at this. Stickers gets the stickers.within.website. And that should trigger external DNS, right? Let's see what happens if I delete this ingress. Ah, it doesn't recreate it. Oh, I confused it, I think. Yeah, I confused it. This is power user stuff. Yep. I am intentionally breaking things at this point to see what happens, so... Ooh, it's not doing it. After I broke it, I think I broke it. Yeah. Yeah, no events. Okay, let's just delete everything and retry. So, yoke, delete app airway, yoke, delete ATC, or mayday nup. How did I apply the air traffic controller? Yoke, delete, dash dash namespace, ATC, ATC, yoke inspect. Oh, that's a nice table. So if I go down to air traffic control, we see that there's that there. And if we apply the airway, then we have a successful takeoff. Then if we apply stickers, reconcile successful. You're still here? Yeah, I'm about to finish for the day. I just want to get something working. Okay, good. We have that in there. And if we go to the external DNS namespace, we wait a second, and it will realize that there's a new ingress and hopefully create resources, DNS records. It only does it once a minute, and it does it pretty late into the minute. Okay, we have created the DNS zone. And if we go down to the certs, we see that stickers is ready. And if we go dig, we see that works. And then if we go here, we have the sticker tester working. So we do NUMA, delete. And there we have deployed an application using secrets. And the reason why it's using secrets is because this sends a pre-signed S3 URL. Awesome. Oh my goodness. It just works. This is so great. I love it. I'm gonna write about this probably tomorrow. I'll use cheer, yeah. Yay! We did it. Anyways, thank you all for watching. Thank you all for... Right to where? My blog. I'll link it. Let me just commit this stuff real quick. Git VS Code, GitHub Z. Make a new repo. We'll call it yoke stuff. And then git status, git add dot, or rm-rf inline basic K8s API, or Redis. Go mod tidy, clean that all up. Gotta jump too. Thanks so much for this. Bye. Yeah, stay safe, yo. I'll add a readme and stuff over the weekend. But yeah, thanks you all for watching. Have a good day. Stay safe, stay warm, stay dry. Go hydrate yourself, make sure you're fed, and don't get sick. Getting sick sucks. Like, a lot. Like, a lot. See you next week. Actually, yeah, I'll see you next week. But for everyone else, I am not going to be streaming next week because I will be flying from Rochester to Los Angeles. Anyways, stay safe, all. Have a good day. And